We're going to talk about central angles today. So what is a central angle? You have a circle, and at the center of the circle, right, you've got the center, which is a point. Now, imagine you draw a radius from the center. Now you draw another radius from the center, right? What have you made there? Those two radii have made an angle. Where is the vertex of that angle? The center of the circle, right? So the vertex is at the center of the circle, meaning this is a central angle. So that's all a central angle is. It's just an angle where the vertex is at the center of the circle. Now, look at this situation here, okay? I have 1, 2, 3 angles. Now, suppose I start with angle 1, and I go to angle 3, and then I go to angle 2 and back. How many degrees have I walked through? 360, right? So all of the central angles in a circle add up to 360 degrees. Okay? All right. Well, look at this one now. We want to find the value of x, okay? You've got several central angles here. In fact, there are 1, 2, 3, 4, 5 central angles, okay? So you say, all right, I'll just add them all up and set it equal to 360. But when you do that, notice there is one angle missing. But you can get around that because look at this. What's RV? You can assume that RV is a diameter. So if RV is a diameter, right? How much of the total angle does that correspond to? Half, exactly, right? So RV is a diameter. That means this is half of all of the central angles. And if all the central angles would add up to 360, half of them would be 180, right? So that much is 180 degrees. That means I can add all this up and set it equal to 180 degrees. Okay? When I do that, I have 26x minus 2 is equal to 180. 26x is 182. X is equal to 7. And from that, you can figure out like the individual angles as well. Okay? Questions? All right. Suppose there was a circular track field and you wanted to walk around it. Okay? Now, if you walk the whole field, you've walked the circumference of the field. If you walk a portion of it, right? That's a portion of that circle. Well, it has its own name. It's called an arc. So an arc is a portion of the circle and it's got 2 endpoints. So if you put 2 points on a circle, the portion of the circle that joins those 2 points is an arc. All right. If you happen to have a central angle, that central angle separates the circle into 2 parts, right? Here is the central angle. Imagine these are like, boundaries of a country. I've separated my circle into 2 parts. Each of these is an arc. Now, how do we measure arcs? We measure arcs in degrees. Okay? That's exact. We're going to talk about all of that right now. All right. So there can be 2 types of arcs. One is a minor arc. So what is a minor arc? A minor arc is an arc that measures less than 180 degrees. So remember we said if you go around the circle, that's 360. And we said the diameter defined an arc of 180. If the arc is less than 180, we call it a minor arc. Now, how do you write the name of the name of a minor arc? A minor arc is named by the letters of the two endpoints, right? So just two endpoints. So for example, this one is arc AB, or it could be arc BA. Okay? You can switch that just like segments or lines. Now, what about the measure of the arc? The arc measure is equal to the measure of the central angle. All right? So in this case, look at this central angle. It's got a measure of x degrees. What is the measure of arc AB? X degrees. Okay? So I think that answers some of your questions, right? Now, that's a minor arc. A major arc is an arc that measures greater than 180 degrees. Meaning, it's obviously much bigger than a minor arc. How do we differentiate between the two? Major arcs are named using 3 letters, exactly 3 letters, not more, not less, 3 letters. Which 3 letters? Well, it's the 2 endpoints and another point on the arc. So for example, for this one, it's arc ADB. Or you could call it arc what? BDA. Okay? All right, so or BDA. Okay? Now, look at the circle. If I refer to an arc as arc AB, AB has 2 letters, meaning it's a minor arc. So you know that it's the blue one and not the red one. All right? So there's really 0 confusion. Well, how do you find this one? If this much was x degrees, well, how much would the rest of it be? It's 360 minus x. So it's 360 minus the measure of the minor arc, if it's got the same endpoints. So how much is the measure of arc ADB? If this is x, then ADB is 360 minus x. All right, we've talked about a minor arc, which measures less than 180 degrees. We've talked about a major arc, which measures greater than 180 degrees. Well, what if an arc measures exactly 180 degrees? How much of the full circle is that? 180 is exactly half the circle, so we call that a semicircle. Not a minor or a major arc, it's a semicircle, and it measures exactly 180 degrees. Semicircles are named by the letters of the 2 endpoints and another point on the arc. So again, 3 letters, just like the major arc. And it measures 180 degrees. So in this case, measure of arc ADB is what? 180 degrees. All right? Okay, so here's an example. We're given some of these here. We want to find the measure of each arc. So I see a circle like this, a diagram like this, and I'm given the central angle. The first thing I do is go and label the arcs as well, because that's easy. And it's good practice to do that, because later on we're going to be talking about inscribed angles and so on, and those are different. So this is 122 degrees here. All right. This is 122 degrees. I need to find measure of arc GH. That's the first thing that I'm asked for. And that's 122 degrees. Okay? Because let me just sit. Okay. The next one is angle arc GLH. So where is arc GLH? Arc GLH is this one, starting from G, going to L, and to H, right? Well, how much is that going to be? 360 minus 122, which is? Right. Okay? And then we have measure of arc GLJ. GLJ defines a semicircle, right? That's from one end of the diameter to the other. So it's 180 degrees. Okay? All right. All right, now these are some theorems which pretty much they're common sense. So in the same circle or in congruent circles, right? So when you compare measures of arcs, they have to be in congruent circles, because if you make the circle bigger, the arc becomes bigger and you can't compare the corresponding arcs. So in the same circle or in congruent circles, two minor arcs are congruent if their central angles are congruent. Okay? So if angle 1 here, if the central angle 1 is congruent to angle 2, then FG is congruent to JH. All right? Now, we've talked before about the angle addition postulate and the segment addition postulate. Now we have the arc addition postulate, right? So if you know the measure of arc XY and you add it to the measure of arc YZ, what is that equal to? The measure of what? The measure of arc XZ, right? Okay? So let's use that here. We have that angle DFA is 50 degrees. CF is congruent to FB. And we need to find the measure here. So here's what I do. Before I even start on the questions here, I go into my circle and I try to label anything and everything that I can. So look, if it's 90 degrees here, that means it's 90 degrees here. So how big is that angle? 40. Okay? How much does that make? This right here. This is the diameter, so it's 180 right here. So if that's 50, then this is 130 degrees. This is 180. And if this little one is 50, then that's 130. Well, this and this are vertical angles. So yeah, so these two are vertical angles, meaning that's 50, right? And now that pretty much completes the circle for me. What I can do now is I can say that each of the corresponding arcs are the same measure as their angles. So this arc is 40 degrees, this one is 50 degrees, this is 130 degrees, 50 degrees, and what about CB? 90 degrees. So now I need to find measure of arc BE. Well, I already know that. That's 50 degrees. ACE, right? A to C to E. You just have to go in the same order. You can keep adding the individual angles, or you'll say, okay, look, there is a diameter here. That's 180 plus 50, 230. All right. What about DCB? If you add D to C to B, how much is that? D to C to B, that's 130. CBE, C to B, that's 90. To E, that's another 50, so 140. Arc CD is how big? And how about CAE? 220. Okay? All right. So let's move on to arc length. We just talked about arc measure, Arc measure is measured in degrees, and it's the same measure as the central angle that makes the arc. All right? Now, what about arc length? So let's go back to that circular field example. If you do have a circular field, and if you want to walk around this field, right, you're not going to tell your coach, oh, I walked, like an angle of, 37 degrees. Or the coach isn't going to tell you, you know what, go walk like 25 degrees here. No. He's going to tell you, or she's going to tell you, you have to walk 3 meters. You have to walk 2.5 miles. You have to walk this many yards. That's measured in linear units, centimeters, meters, and so on. So there's a clear difference there. Arc measure is measured in degrees, and it's the same as the central angle. But arc length, that's part of the circumference, and it's measured in linear units. Okay, like centimeters, meters, and so on. All right, so how do we figure this out? All right, let me give you an example here. Suppose this is your circular field, okay? Now suppose the radius is, it's 5 meters. Okay, the radius is 5 meters. Now, look at this. If I make an angle of 90 degrees here, right? This angle, this central angle, how much of the full angle is it? How much of the full angle is it? If it's 90 degrees, it's 1/4 of the full angle, right? So 90 over 360, that's 1/4 of the full angle, right? Now, that angle just portioned off how much of the circle? 1/4 of the circle, right? So if this was a pizza and you cut it at 90 degrees, you've portioned off that much of it. So many weird people. All right. Things happen. Okay. All right. So I drew a 90-degree angle here, and it's 1/4 of the full 360. Well, what I did is I sectioned off how much of the circle? 1/4 of the circle, right? And if you had to look at the outer circumference of this, how much of the circle have I portioned off? 1/4 of the circle. Right? So now, this 90-degree angle, it's 1/4 of the full angle, and it corresponds to 1/4 of the distance around the full circle. We can write that as a proportion, right? How does the proportion for that look? Well, let's call this distance L. That ratio of the distance L over the entire circumference, that's 1/4 of it, right? Well, that's the same ratio as this 90-degree angle over the full 360. You see what I mean? So that is an equation here. It's a proportion. So L, which is this length, the ratio of L to the entire circumference is the same as the ratio of X to the full 360. Okay? All right. Let's move on to this next one and use that in an example. No. So we want to find the length of ZY. This is what we want to find. I call that L. So the length of that portion over the entire circumference is equal to the central angle 45 over the full angle 360. So how much is the radius here? So it's L over 2 pi times 12 is equal to, can we simplify 45 and 360? How much is it? It's 1/8. Okay? And now 8L when you cross multiply, is equal to 2 times pi times 12, meaning 8L is 24 pi. So L is 3 pi. Okay? So if you're asked for the exact answer, that's what it is. It's 3 pi. All right, let's do this next one. Points T and R lie on circle W. So here's point T, here's point R. They're both on circle W, so that WR is 12. So circle W, meaning this is circle, the center. WR is 12. And angle TWR is 60. So that angle is 60 degrees. Okay? What we want is the length TR. So this is what I want, L. All right? So what's the proportion here? L over what? 2 pi times 12 is equal to 60 over 360. So L over 24 pi is equal to 1 over 6. And look, I can even cancel these out. So I get L over 4 pi is equal to 1 over 1, meaning L is equal to 4 pi. Okay? You can cancel horizontally and vertically. So that's that. So this homework will be due tomorrow.